Again, and welcome to the Science of RVs. It's Andy, and today we're going to talk about heat loss and, in particular, radiant heat loss. Now, why is radiant heat loss important? Well, we know that there's three types of heat loss: radiant, convection, and conduction. Convection is just swirling of air. Air gets hot, it rises because it's more buoyant. The cold air drops, and you end up with a circulation. Conduction, you heat one end of a metal bar, the other end gets hot. Radiant, well, radiant heat is an atomic type event. All the heat from the sun comes by radiant heat all the way through the universe, and when it hits something with matter or mass, it converts from a radiant heat to a latent heat within that substrate. So, if radiant heat hits something, it'll get hot. And we all know that our car gets hot when it's out in the sun. Our RVs get hot when they're out in the sun. So a big proportion of the heat that comes into our RVs and almost all the heat that leaves our RVs are by radiant heat. Is that true? Well, let me think about my RV. I've heated it up. I'm now nice and cosy inside, and it's cold outside. What is my RV actually touching? Well, it's stood on a couple of tyres, maybe four. It might have a couple of ramps. So there's not a lot of contact with other mediums other than the air. So conduction isn't going to be a primary driver of my heat loss. Convection? Well, convection works by there being a hot surface. So there will be some convection off my roof if my roof has got hot because of the heat inside. But predominantly, I'm going to shed this heat through radiant heat loss. So my surfaces are going to beam this heat out because of their temperature being high. However, we can reflect that heat back to its source. So if we lived inside silver foil, all that radiant heat from our bodies and inside will get reflected back to us. And likewise, if we put foil or we've got polished aluminium skins, which some of us have, on the outside, it will reflect a lot of that radiant heat away. Now, how is that demonstrated? Well, here's a simple experiment. Some simple silver foil. Aluminium is a great reflector of radiant heat. So how can we check whether that works or not? Well, simple experiment. Put the foil right about an inch or so from your face and wait. And over a little bit of time, you'll find that I can feel it already. My nose is starting to feel a little bit warmer because the radiant heat out of my face is hitting the foil and coming back and being absorbed by my skin. Whereas the temperature behind the foil isn't changed at all. My nose is getting nice and warm already. So that's radiant heat reflecting because there's a little gap and it's hitting the reflective surface and coming back. Now, what happens if I put that material on my face? Well, it's not reflecting anymore because I'm in contact. So I'm conducting the heat of my face straight through the aluminium, and I can feel the temperature of my face on the other side. So for a radiant barrier to work, it's no good it being in contact with another medium, because all it will do is conduct the heat through it. You have to have a gap, and that's where some of the aluminium foil insulation products are not used properly. So we know what kind of products they are. It's basically bubble wrap covered in foil. And a lot of people use these on the inside of conversions because they feel that it's giving them some kind of thermal benefit. Well, if there's a gap behind it, and the gap has to be an inch to an inch and a half, like this, then you're going to see great benefit because it's going to reflect that radiant heat straight back towards its source. However, the closer it gets, the more and more it just starts conducting the heat away, and if it's in contact, it becomes completely useless as a radiant barrier, completely. So that's the mistake that people make with these silver foil lined products. People put them under the floor and then put board straight over the top of them. It's not going to reflect any radiant heat because it's just simply going to conduct it through the surface. Likewise, people put them on walls. So they'll have the, say, metallic skin of their RV. They will then use a foam product with this on the surface, and then they'll put they'll put a boarding on top, or they'll clad it. This isn't doing anything for you. and it's not going to work on the inside coming out. So if there's foam on this surface, the heat's going to hit the foam. The foam's going to absorb the heat, and then it's going to conduct it. Now, what it will do is, if heat's come through the back, this also will not emit radiant heat. It'll reflect it. It won't absorb it. It'll absorb very little. It won't emit it either. So if it's on the inner surface, it'll stop that heat that's inside the panel being radiated. But again, only if there's a gap. If it's very close to something, the heat will pass through convection or conduction, and it's negated its use. So that's a big mistake people make with these radiant foil barriers. It must have a gap. So if you're going to use it, surface of your vehicle, gap, radiant barrier, then insulation. There's a product called Celotex which has a silver foil on the surface. Now that silver foil is there strictly as a moisture barrier. And because it's got printed information on it, it's not as effective as something that won't emit radiation. So better would be a pure foil surface like this. So how does that help us inside our RV? Well, because we know that the skin of our RV is going to get hot and we don't want that radiating inside, if we clad everything with a thin layer of silver foil, it would not allow the heat that's within the skin of our vehicle to be radiated to us. It can be conducted and convection, but not radiated. But you don't want the inside of your RV to look like this. But wherever you can put this with a gap will give you benefit. So inside cupboards overhead, cupboards down below, on the inside surface of the walls, if there's a little cavity between that and your insulation, this will help keep the heat in the skin of your vehicle and not inside your vehicle. So that's one way of using it. The other issue with radiant heat is obviously different things absorb heat at different rates, and unfortunately it goes straight through most transparent materials like windows. Now you can get e-glass which reflects a lot of it back, and the absorption of e-glass is about a 20th of something that absorbs everything. So black absorbs everything, and it's got an absorption of 1. Matte black, perfect black, it's got an absorption of 1. Aluminium foil is 0.05 or 5%. So it reflects, it only absorbs or only emits 5% of the radiant energy that hits it, whereas pure black absorbs it all. Treated e-glass is about 20%, but glass ordinarily is, if I look at my table that I'm flashing in front of you, glass is of the order of 90+% for most glass, 90 odd percent. So glass, come on through, let the radiation in. Steel, or aluminium, any polished surface will be of a fraction, it'll just reflect most of the material. So aluminium, copper, polished steel, steel as an element, steel sheet is about galvanized about 28%, so it still absorbs about a third of the energy. But glass is the killer. So what can we do about that? Well, if we haven't got e-glass, what e-glass does is it has metallic chemistry on the inner surface of a double glazed panel, and so it reflects the heat away. We can do that by using some of the foam product, the foil products that you can get, and we can put them on the inside of the glass, but with a little gap. So that's why some blinds that you can get, if they've got a foil backing, can reflect it back at the window and straight back out. That's one way of helping. But of course, the best way is to make sure your windows are in shade. So get your awnings out, stop that radiant heat hitting your windows in the first place, and then all you're doing is managing conduction. And conduction is managed by plenty of thick insulation. So I hope that's clarified a little bit more about the use of these reflective barriers. As an insulation, a little bit of bubble wrap is adding almost nothing. Again, if you think about a house, you'll want 200 millimeters of mineral wool insulation to insulate your house from heat going up through your roof. So what's that going to do? Best will in the world. it ain't going to stop a lot of conduction. And if it's got a metallic surface, even worse. So as a conductive barrier, these products are really not effective. As a radiant barrier, they're only effective if you don't stick them on your face. What am I really trying to say? What I'm trying to say is, if you've got a nice aluminium RV, keep the surfaces polished and clean, and it will reflect a lot of radiant heat from the sun back away. Keep your windows in shade much as possible. If you're going to use a radiant barrier, use it immediately on the inside of your skin and make sure there's a cavity of at least an inch. And then put your insulation in and have a radiant barrier facing the radiant barrier, either side of that cavity. And what that'll do is it'll make sure that the heat just doesn't get into your RV. Then have your insulation as much as you can bear, and then just put a moisture barrier and clad. So that's to keep hot out. To keep hot in, then if you do have any radiant barrier, so anything that's emitting heat, if you can stick it inside cupboards and so on so it doesn't look rubbish and there's a gap, great. Other than that, don't bother with it. Just put your insulation in. If your insulation is straight on the outside of the vehicle, no point putting any radiant barriers on because it's just going to conduct through. If your insulation has a gap between it and the wall of your vehicle, put a radiant barrier foil on each surface. And that means that your insulation won't radiate the heat into that cavity, and when it hits the other side, it's going to reflect it back into the cavity, which doesn't make sense, except that you want to keep the hot heat in summer out. So that's probably a compromise you'd have to make. Personally, what am I going to do? I'm going to coat the inside of my skins with a radiant barrier wherever I can, and leave a cavity. I'm going to have a radiant barrier then on the outside face of my insulation and leave that cavity, and I'm going to put as thick an insulation as I can. That's how I'm gonna tackle it, and that way the heat stays in because of my insulation, the radiant stays out because of the radiant barrier that I have. So I hope you found that useful. Used properly, they can be a great benefit. If you're not going to use them properly, don't even bother. Some people use them as a moisture barrier. Bit of plastic would do the same and be a bit cheaper. This stuff's about £2.50 a square metre. Inside a decent size RV, you're going to spend 50 bucks lining your vehicle for what? You could do it for a £5 with some plastic. Okay, hope that was useful. Bye.